So realizing that we are creating more problem, I teamed up with a well-known meteorologist, Roland Madden. We started to see, when are we going to see this warming? Okay. There's other thing I want to point out. Although many of you are reading about the problem in the last 5-10 years, scientists working in this field, just not only me, but almost all scientists working in the field realize it's going to be a major problem. Look at how we start the paper. We are saying the possible climate effects of large increase in CO2 may constitute one of the important environmental problems of the coming decades. So this was sort of, we knew this. We meaning I'm talking about collectively. And in that paper, it was a detailed quantitative analysis of temperature records and models. We said we should see this warming by year 2000. So this was a prediction, and this whole detection and attribution has become a major field now. I'm pleased to see there's so much work going on. Unfortunately, that prediction was also confirmed in this IPC 2001. So look at the temperature records. Okay, it has hiccups, goes up, goes down, goes up, and then has been going up. Our paper was published in 1980 when it was going down. So when my paper came out, I remember so many meteorologists said, "You're crazy. We're going through a cooling trend, not a warming trend." And you can see by year 2000, this was what we were quantifying, the so-called variability. And we said it'll rise above the so-called noise by year 2000. So given that, I'm in 2008, myself and my colleague Fang came up with another prediction that forget about the future increase, using what IPCC said is how much we have thickened the blanket, and IPCC's estimate of climate sensitivity, that is the warming we compute, what the planet has already put in the bank. It's already in the bank. Okay? The interesting thing is, the last 4 or 5 years we are realizing there is no such thing as going to be a one warming. It's a probabilistic thing. So the warming, the median, or that it's going to warm by 2.5 degrees, but there is a 10% probability we have overestimated it. Okay? But there is a 10% probability the warming could be as high as 4 degrees. So the question I ask the policymakers, what are you doing to hedge against this possibility? Okay? Most of us are thinking about this 2 degrees. In any case, overlaid on that, I put the so-called iconic changes. It's coming from a paper by Schellnhuber. He was a science advisor to Chancellor Angela Merkel. So we know, scientists say, anywhere between 1.5 to 2.5 degrees, the Arctic summer ice may disappear. And the one I'm focusing on, to me it's the most ominous, is the potential disappearance of the Himalayan Hindu Kush Tibetan glaciers. Why is that? I'll talk to you about that. Now the question you can ask is, well, you're saying we already committed the planet. All we have seen so far is only 0.6 of a degree. What happened to the rest? Either the model is wrong or something is going on. And it is something I started looking for. Since 1995, I'm going to bring in now air pollution. Particulates, aerosols it's called. I'm going to call it atmospheric brown clouds. So one thing I want to tell you about my research is I have to touch and feel it before I trust anything I do, or at least I should be able to see it. So the aerosol brown cloud, I don't have to tell Los Angelinos about that. You can see the brown cloud. Unfortunately, this was taken just 3-4 years ago. Okay? So is it an urban problem? That's what we thought. And until we did this experiment in 1996 to 1999, it was originally proposed by Professor Paul Crutzen and myself. Later, over 200 scientists joined. India played a major role, and there are many European nations. I want to show you quickly what we discovered. See, our whole idea is, the northern Indian Ocean is subject to pollution from South Asia, and then Middle East and Saudi Arabia, etc. So we thought we just take a ship and go north and south and take planes north and south. I'm comparing smoking versus non-smoking, to use a metaphor. Okay? So we compared air mass. Look at what we found. First of all, the entire Arabian Sea was filled with these brown clouds. So we know it's not an urban problem. Okay? It's a large-scale regional problem. And then see what we found. Mother Nature produces these beautifully looking particulates. We call them sea salt or sulfates. What we found, and this is typically what you would find if you do the same analysis here, this is basically transmission electron microscopy. You take filters, then go to the lab and analyze it. So you can see every particle was attached with this ugly looking soot. Okay? We had to go 3,000 kilometers away from the source to see natural particles. And we already saw from the movie, there's no place in the planet we have not impacted. Okay? So what did we found? I think what was discovered in the report in these two papers, but other papers, that these particles what's now called global dimming. Okay? We know that when the sky is polluted, it's hazy. Why is it hazy? It's bouncing some sunlight back. That was known. What we discovered was that dimming was also caused by this black carbon absorbing particles. So you can intercept sunlight two ways. One, bouncing it back, mirrors. Okay? So let's go back to this blanket. I want you to keep this blanket on. Don't go to sleep, just keep the blanket on. We have put mirrors on the blanket. The blanket is trying to warm you, but then we have put the mirrors, it's bouncing the heat, it's trying to cool. But in addition to that, we have filled this blanket with dust, soot. It's trapping sunlight. So making this blanket an electric blanket. So it's got two sources of heating. One, greenhouse gases, another sunlight. Okay? And this was, we really caught this in its act. We will take the ship, go in and out of the plume. That's the clean air, the sunlight, and the polluted air, almost 30% cut down. The magnitude shocked us. And to this day, I've been asking marine biologists, what does it mean to impact on life on the oceans? Everything depends on sunlight. But I'm focusing on the climate. So we took this data, put it all together with various ground observations, aircraft, and satellite observations. Remember, I said I don't believe anything until I can touch, see, or feel it. So when we assembled the data and put it together, that is the dimming, decrease of sunlight in the ocean. Okay? But some of that is because these particulates, the dust in your blanket is trapping, that's the heating. If you look at what the greenhouse gas is doing, its trapping is somewhat uniform. These particulates is, patchy, because their lifetime is still small enough. It's concentrated close to the source. I'm going to first talk to you about this dimming. Look at how over most of the northern hemisphere ocean we have cut the sunlight. Okay? And I want to focus on, again, I'll come back to that, the heating by the soot is now thought of responsible for the Arctic sea ice. See how much heating is going on, see how much of the glaciers. Okay? I don't have proof for this yet, and I'll show you later, but this I have. I showed you direct observations. So, sorry. I'm well known to miss my punchline. I missed the punchline in this. Remember, I went looking for this missing heating, right? The prediction is the planet should have warmed by 2.5 degrees. We have only seen a quarter of that. So what happened to the missing? So when I add these two, that's what we get, a minus. So the brown clouds or aerosols have masked the greenhouse forcing by almost 50%. IPCC value is more like 42 to 43%, and their values are largely derived from models. So it is sort of reassuring. Coming independently, we are not that far off. So that's the reason we have not seen the warming.